Swayam Prabha. Digital India. Educated India.
Please think that there is no process in nature. After all, whatever mathematics you study, we are simulating something in nature. Please tell me 2 or 3 examples where something varies a 6th power or 7th power, 8th power, 9th power polynomial in nature. Simplicity is king. So linear doesn't work. Okay. Quadratic, cubic, that's it. Okay. So all other complications are, we can probably try to use some non-polynomial regression also. All right. So that is a problem with IITians also, right? So I'm also one. So we tend to complicate things. We don't know that there is a simple way of doing this. We are also looking for its character. It has to be the character. Why should it be character? Let it have 5% error. If it is having 5% error, there is a smart and simple way of solving it. Somehow throughout our system, we have not trained the students to do that way. So it is basically, it is there in that book. It is there in Piskunov. It is there in Iridov. It is there. This is the way we have done. This is. So because you don't even question whatever Newton, other people say, this has to be, this has to be, this has to be. That faith we should have in phenomena which you are observing. So we are trying to understand nature. So mathematics is only a tool. Please note that. It's not that I'm weak in mathematics. You know that I have a flyer for maths, as you can see, my board work. Okay. But it's a very good field. Mathematics is a very good tool to help us and all that. We have achieved a lot of things. But there are also non-mathematical roots to a problem. Data science is one such approach. There is mathematics inside neural network, whatever, but ability to recognize patterns, ability to recognize the correlation between independent, dependent variable, that skill will not come just by solving equations or framing equations. That has to be learned. You should have an acute awareness of the phenomena. Okay, often that is missed. Yeah, we are looking at only the mathematical equivalent of the problem. Often. Okay. Okay, now what are the ways by which this can be solved? So you can solve it using matrix inversion. I already taught you. You already learned. Yeah, please mute yourself. So if I'm making host, I'm in trouble. Okay, I don't do that. Okay, matrix inversion, Gaussian elimination. Array, see this? Okay, matrix inversion, Gaussian elimination. Now, the class should be like a penance. Okay, that's why in the classroom, Zoom, and all that. Somebody is calling and, sir, I'm sorry, sir. Simply you say sorry, then we'll forget. We may be discussing some very important things. Okay, and he will say, I'm in a class, so I told in Tamil. He said, I'm sorry, sir, you wouldn't know. Sorry is not the cure for all the problems, right? It is very easy to say sorry. But we don't know whether somebody is really sorry. It comes automatically. All right. So matrix inversion, Gaussian elimination. Gauss seidel method is a powerful tool which can be used for many variables also, right? So let's learn that. Just in case you encounter a cubic or something. Okay. Cubic is possible if the heat generation is linear, which is quite possible. If the heat generation is linear or quadratic, then the final temperature in our problem, yesterday's problem, could be cubic or quartic. Okay. So that will be the, beyond that, it won't happen. Okay. All right. So the Gauss Seidel iteration. How many of you don't know the Gauss Seidel iteration? Even if there are 2 no's, it's. How many of you don't know? Just say I don't know. Or if you say I know, we'll proceed. Everybody knows. 70 students are there. Don't know. Okay, so somebody says, Anand says, can you apply what that Z transpose is Z panda? You try to solve it and see. Anand, you just check it yourself. Okay, don't try to test my memory. So I remember very few things. But Anand, if you have to answer your question, I will take paper and pencil and try to solve it. Okay, so try that way. Instead of quickly asking the teacher a question, you should ask these things. So that transpose T will work. You can check it yourself. Okay. All right. Okay. I think it should work. Anyway, that is the question. So since people don't know, so I worked as a Humboldt fellow in Germany for a year, and I worked in the lab in Hamburg for several 1 year once, then 2 months, then again 2 months. When I was in my 30s and 40s. Okay. So the last one was in 2012. So the German professors often say that Indians are, Anand, I'm not mentioning you, you're a hardworking student. Indians are very quick in seeking support. Indians very quickly want to ask the professor, what is the answer? What is the answer? What is So he says that let it take time. It is not the answer, it is the process. So he says that this is among all the students, they say that Indians, they want quick answers. They would, if they are not able to get quickly, they will go to the professor. I want the answer. They say you take a few days, search for yourself. So they actually they say that no, for PhD students, they don't have coursework, Maybe some PhD students in Germany, they see that when you're coming to a PhD, what is the point in attending a lecture and taking an exam assignment? Learn it yourself. Okay, so that is their idea. So many times you should learn yourself. There is no teacher to certify you whether you have learned it or not. You learn it in the way you want it. All right. So of course, material will be available, prof will help you and so on. At least for PhD level, there is no coursework. But US, they'll have so many courses. Okay, they'll have so many courses. That's a different system. Germany, 4 years directly thesis work, right? If something has to be done, either the prof will have a contact us or you have to go to some other prof, talk, he will give a reference, you go to the library, bibliothèque, and then you take down notes, have a discussion with the prof, he will sort out some doubts. So that self-study is there. But some Indians are terrorized. The idea of self-study is terrorizing to us. Okay. So that's what we try to do when somebody comes MS, at least in your project, dual degree or MTech or MS or project, it is self-study. That's why it is terrorizing to many people because we are so used to some prof will come and speak. He will give questions. Some more you have to answer the questions. Even if you don't study much, if you're able to answer the questions, it's good. So that has been there. So you and I are not. It has been there for us for hundreds of years. What can we do? So the only place where you do a difference is basically your mini project, your ME 4001 undergraduate research project, your MS PhD project, dual degree project. So please take your project seriously. It is not that actually you learn, if you do a good project, you will learn a lot more because there is no upper limit. So you are going to work, the prof only helps you. So if you're able to show more interest, the prof will automatically show more interest. That is natural. All right. Anyway, so the Gauss-Seidel iteration, consider consider a set of linear equations. So I'm sorry that I have to start with 1. Okay, again. Okay, then A21. Yeah, what is the last entry? Tell me. No, no, ANN. Come on. Be sharp. It's not ANN. Is it ANN? Ah, correct. This is ANN. Correct. So when I have something which is not ANN, just wait. After a few equations. Okay. All right. This ANN is for ANN XN. Correct. Sorry. This is fine. So we can put it in a nice matrix form like this. A11, A12, A1n, A21, A22, A2. I thought somebody taught it in linear algebra. You took optimization course with S. Balaji. You would have taught you. But at least good. Don't go out of IIT without knowing Gauss-Seidel because this is the basis of a COMSOL, Fluent, ANSYS Fluent, Star CD. All the CFD equations, the backbone is a set of linear equations. What is a set of linear equations? How temperature at a particular node is related to the neighboring nodes. How the velocity at a particular node related to the other nodes. If it's compressible flow, how density at a particular node is related to the other nodes. So since in 2 dimensions it could be east, west, north, south, and in 3 dimensions east, west, north, south, front and back. Okay, and then there can also be north, east, south, west. So that is called a stencil. STENCIL. What is stencil? How many points surrounding the point under consideration are taken for discretizing? Discretizing means dt by dx is ti plus 1 minus ti divided by delta x. Dt by dy is tj plus 1 minus tj divided by delta y. D square t by dx square is a little more difficult. Like that, u dou t by dou x, u dou u by dou y, u dou u by dou x can be written as dou by dou x of half of dou by dou x of u square. All that. So what I'm starting today is, this will be the first 2-3 minutes of a CFD course. Okay. So ANN. Oh, Balaji will teach you. I am also Balaji. When I say Balaji, it is the other Balaji. So Balaji will teach you ANN. That is ANN, not small a subscript n. That is artificial neural network. So enter X1. Okay, very nice. So it's got a compact form. So though I keep on asking you to have caution on maths, maths is elegant. Maths is beauty. I mean, so I love maths. I learn numbers, but sometimes that can be our limitation. Okay. The Q is equal to HA delta T is a major limitation of heat transfer people. We are not able to come out of it. I'm looking for some nice chalk piece. Dust plus. This is that. Apsara. So prof started taking, okay. First they gave 60 plus, then 45 to 59. I'm in between, you know. So I have mild hypertension, so I'm eligible. But last week I had some allergy. I'm dodging. I'm just waiting for, I'm just buying time. Yesterday that Covishield was not available. So Vasaji, I mean, Dean students, and they just put Covaxin for 20 people yesterday. So if you go there, you don't have a choice, you know. Whatever is there, they'll give you. If you're going for the free vaccine. If you're going to a private place, you can say, you can find out which place has Covishield or Covaxin, depending on preference, and you can go. And I think you guys should get it. I think, so see, you see, the funda is, they're saying 3 weeks window for 60 plus and 45 to 50, 59. Nowadays, that 20 list is not there. Comorbidity, anything. Heart is pounding, so heartbeat is high. There is some heart problem. There is sinus, there is asthma, the sugar, okay, diabetes, PP, all that they are giving. Okay, they don't even ask for certificate. So they are saying 3 to 4 weeks, this will be over. Then 4 weeks, everybody will wait, correct? And then another 3 to 4 weeks. So 12-week cycle. So we started on March 1st. So 11 to 12 weeks, March, April, May. By the last week of May, this target population would have been completed. I mean, it's voluntary. Whoever is not taken, own risk. By that time, the Serum Institute and Bharat Biotech would have upped the ante. And they are already producing 20 crores per month. So they already, that fellow may be having 50, 60 crores. He is not telling. In fact, some high court is asking the question, how many vaccines do you have? Now, answer is not coming because they are also exporting. We don't know. I think the moment the trial phase 2 itself, the trial was successful, they would have just 3 shifts in their Pune factory, they would have just made. I think they are having lots of vaccines. So you should be able to walk in, and June, July, you should be able to get. Then hopefully we can open the institute, but I think people will wear masks. What do you feel? People will still wear mask, social distancing, but fear will be largely reduced. Any response? Anybody has some other point? This is not inverse heat transfer, but it's okay. It is very important matter. Anybody? Any of your parents has taken it and they're all okay, no side effects? Your granddad, your aunt, your uncle? Anybody? Yeah.
sir. My father and
Yes,
mother.
sir.
Pradeep Rajan, your father took it?
Yes, sir.
Pradeep.
Yesterday he took it, sir.
Very good. Now, no problem. No? 24 hours over. He's fine now.
Like he just had some hand pain yesterday night.
That will get. Here.
Like today he's fine, sir.
Very good. So you can put some ice, this thing and all that. So did he go to office today or no? Home.
He's working at home, sir. Work
Okay,
from
that is
home.
good. Okay. Who else? I heard somebody else.
One
Yes,
of my
sir.
relatives has.
Yeah, who speak one at a time, please? So Subhash.
Yes, sir. One of my relatives has.
He's fine now after the vaccination.
Yes, sir. The day after he took it, there was a very high fever and muscle pain. And then after 2 days, it subsided.
Very good. Then Shalu, is it? Somebody was speaking?
Yes, sir. Yeah.
Shalu,
My
tell me.
mother and grandmother both of them took it, and they had fever and body pain for a day, and then they were.
That is why, see, Monday, Tuesday, Wednesday, I'm having inverse. Monday, Thursday, Friday, atmospheric science, so many meetings in the afternoon. So I'm thinking of taking up Friday afternoon, so that if something comes, you get body pain, fever, at least have Saturday. I didn't want to take it on a Monday because the whole week is there, and already Dean said 1 week no classes and all that. So I thought, I think it will pain. I think that some rash, some bad feverish feeling.
No, sir.
will be there.
My sister took it and she's completely fine. She went to college next day.
Because your sister, she cannot be so old. What is it? She's having some
No,
trouble.
sir. She's a medical student, so she got it.
Okay, so no problem, huh?
No,
So
sir. No,
whatever
sir.
the symptoms
He
are,
went.
I think it'll stay for just a day. As far
Yeah,
as
and also if you see, we have done remarkably well. I believe in Texas and all, people are waiting for 2 months. They're not getting vaccines. In India, somebody is above 45, they want a vaccine, they can easily get it. Okay, and if you go to a government hospital, or you can get it for free also. Okay, so how much it's effective and all that we don't know. At least it will be okay at least. Okay, types. Even if it's 60%, it's okay. Then you do your mask, social distancing, and all that. So eventually, if many people are vaccinated, I think they should be. Here also conference and all that. For example, I have not flown in an aircraft for 1 year now. So this year also conferences, meetings, all the things are all online. So let's see, 2022 will be different. All right. Now, this is so this can be written as Ax equal to B. So x equal to A inverse of B. So if this is the case, you may ask, sir, what is the need for Gauss-Seidel iteration? Very good point. If you're very good in matrix inversion, it is okay. But in CFD, you got millions and millions of points. There's no point in inverting the matrix again and again. So it's better to have an iterative method. So that is why we use the Gauss-Seidel method. Okay. The method works like this. The Gauss-Seidel method. Okay. So you write x1 equal to b1 minus a12 x2 a13 x3 dash 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 a1n xn divided by a11. Yeah, please tell me the last entry.
N minus 1.
What n minus? N minus 1.
N minus 1.
Exactly. That's what this was what I wanted to tell. Divided by an. Okay. Equations are rearranged. Equations can be rearranged. Rearranged to satisfy diagonal dominance. So this is something which is important. Satisfy diagonal dominance. What is diagonal dominance? for all I, mod of ai is greater than sigma j equal to 1 to n. J is not equal to I mod of aij. So this is diagonal dominance for mathematics. Okay. Are you getting the point? If the other coefficients are in a 3, if there are 4 variables, if the other coefficients are 1, 1, 1, the A11 will have a coefficient of greater than 3. But will it always work? Yes. It turns out that in most of the problems in thermal engineering, this diagonal dominance is automatically satisfied, which means you can rearrange the equation such that you can. So use this equation to, if A11 is diagonally dominant, use this equation to solve for 1. If A12 is the biggest, then use this equation, or so use this equation to solve for x2. So I mean, you rearrange the equation such that, see, the funda is very clear. When you divide it, you divide it by the largest possible number so that the errors don't multiply. Okay, because you're dividing. Obviously, needless to say, aia has to be, should not be 0, then the whole thing will collapse. Okay, a being 0 very rarely occurs when you're doing a finite difference or finite volume. So this means that that particular ai is a very strong candidate. Okay, now should this always be there? If diagonal dominance, please note down, if you want you can write down, if diagonal dominance is present, convergence is assured. Okay. So it is a sufficient but not necessary condition.
Sir, no DC were available, sir.
Okay. So it's a sufficient but not necessary condition, which means if diagonal dominance is not there, also you can get convergence. But if diagonal dominance is there, convergence is assured. Then you can do under relaxation, do over relaxation, whatever. So what you do is you just rearrange the equations. For example, okay. No, I'm writing some orbit. Huh? Yeah. Okay, if there are 3 equations like this. So this is so I will write it like this. Huh? X1 equal to Is this okay? Did I write it properly? Please do a thumbs up if everything is fine. Okay. Now, is it diagonally dominant? I've written in such a way that it is diagonally dominant. 12 is the 13 is highest coefficient here, 14 is highest coefficient, 9 is highest coefficient. How does the method work? Take x1 equal to x2 to x3 equal to 1, for example. You substitute the value of 1 and 1, calculate the value of x1. Now, the old value of x3 is available to you, which is 1. The new value of x1 you calculated, substitute these two values and get the new value of x2. Now, when you come here, new values of x1 and x2 are available, not the 1 which you assume. So then get the value of x. Now you calculate new values of x1, x2, x3. With that, you again iterate till This is called the stopping condition. So once you go through the cycle, you get values of x1, x2, x3. Now the new value of x3, put it here. New value of x2, put it here. Get a new value of x1. From x1, you go to this. From here, you go to this. From again, you go to this. So you do the iteration. That is why it's called the Gauss-Seidel iteration. Okay. So the other possibility is x1i plus 1 minus x1i whole square plus x2i plus 1 minus x2i whole square plus x3i plus 1 minus x3i plus 1 x3i whole square norm. Okay, this is less than or equal to some epsilon. That epsilon can be 10 to the power of minus 6, 8, 10. There won't be any teacher, there won't be any prof to fix. You have to fix it for your problem. Okay, so it is all left open. So that is called the stopping condition. This is a very powerful method for solving. This is also used in CFD. This is a good technique which can use for a wide class of problem. It's not only it's important not only in inverse methods, it's important in heat transfer, fluid mechanics, civil engineering, atmospheric science, whatever field, electrical engineering, whatever field you want to work. Is this okay? All right. So now, it has taken 2 classes, but it is well worth it. So this much amount of discourse, I did not do it in the last 2 times when I offered the course. So we are going a little slow, but it's okay. So I established the case very slowly in yesterday's class, taking a slab and this thing very gentle pace. We figured out that something comes as something x squared into something. So there is a polynomial regression. We wrote the governing equations and then we told you the method to solve it. But in that case, QV may be the only unknown, but there could be a second unknown, which could be the surface temperature. If instead of surface temperature, I give the H and T infinity, and T infinity is known, H has to be found out, then H is another unknown in the problem. So you can do multiple, you can determine multiple unknown if you have a set of data, and whatever model we propose is called the forward model. Then there is the inverse model is the least square regression. Instead of proposing like this, the other computational approach to that would be taking 100 values of QV, generating the temperatures, calculating the R square and plotting. This is called a data-driven approach. So it's computational statistics. Suppose there is a 10 parameter problem and the forward model is not just QV x square by blah, blah, blah. The forward model is itself is a solution to the 3-dimensional fluid flow and heat transfer in a nuclear reactor. Okay. Or the stresses on an underwater vehicle or something like that, then you can't do this computational strategy. So therefore, obviously towards the end of the course, we will teach you techniques where directly computational statistics will be used instead of least square regression, number 1. When you do that, there should be computational economy. Therefore, suppose you're choosing 100 values of QV, what values of QV you will choose? So there should be what is called a method in the madness. Okay. The samples you generate, there should be a method. So many statisticians have worked on this. So one powerful technique is the Markov chain process, where the next sample is dependent only on the previous sample. So Monte Carlo methods, Markov chain methods. So, and then using the Bayesian inference where our prior knowledge we are using. So with all this, we'll be able to solve problems which are very nonlinear, in which this least square regression does not work. Right? All right. So now let's go to problems involving transient conduction. Okay, example, the re-entry vehicle. We already saw that in the earlier class. Estimation of Q on the surface. Estimation of the surface heat flux to design the thermal protection system. Okay, cooling of ball bearings. Propagation of heat below the soil. transients in electronic cooling. So these are some of the examples. That means unsteadiness. There is a sudden spike in the power, there's a sudden spike in the voltage or current or something, no? Transients in electronic cooling. In all these cases, there is a unsteady heat transfer which is involved. That is, temperature is a function of time. Okay, the key parameter is the Biot number or the Bio number. Okay, Bio number is HLC by K. This is solid. H is the heat transfer coefficient. This is the Biot number. Which is the heat transfer coefficient. This is characteristic length. So any irregular object, you can take the area of the volume to surface area. If Bio number is less than 0.1, T is a function of T alone. So in a body, even if it's a slab, we don't have to worry about whether T is a function of the radius, T is a function of the length, and so on. So T is a function only of time. So in these cases, so it gives us a handle. What is the inverse problem here? We will see. So any doubts so far? Okay. Now let us consider a transient conduction problem. Okay. So there is a thin plate. There is a thin plate. Okay. So I put something L, W, and T. Okay. K, rho, Cp, they're all constant. QV equal to 0. Bio number is less than 0.1. T is a function of T. These are the assumptions. What is the situation here? It is a hot plate. T equal to Ti at time T equal to 0. The plate is heated, or it could be a ball bearing, whatever. In this case, I made it as an aluminum plate, for example. Now, at time T equal to 0, it is kept in cold surroundings at H and T infinity. And Ti is greater than T infinity. Are you getting the situation here? So consider that this notebook is a heated plate. It is heated, it is thin, such that, why is it thin? That HLC by K, L should be very small, V by A, or it should be a material with high thermal conductivity, or there should be low heat transfer coefficient. Any of these three or a combination of these three can make the Bio number less than 0.1. Sir, what happens if Bio number is greater than 0.1? Write a computer code and solve it. It's not, doesn't mean that we cannot solve the problem. But Bio number less than where I can demonstrate it in the class, and once you demonstrate it for this kind of system, once you appreciate the funda, you will be able to solve difficult problems. That is the whole, that is a way of gaining knowledge. Okay. So it is suspended. Okay. From 100 degrees, it is kept in cold surroundings at now 30 degrees centigrade. What is the situation now? What will happen to the plate? What will happen to the plate? For the plate temperature?
It will cool down.
It will cool down. Very good. Okay, it will cool down. So the thing is, M into Cp dt by dt of the plate equal to minus HA into T minus T infinity. I'm sorry, I'm using one again. M is the mass of the plate. M equal to rho V. Cp is the specific heat and T is the temperature. Let theta temperature excess be T minus T infinity. Now MCP initial condition Okay. So this is called the forward model. So I'm going to give you 5 minutes. Okay. You're going to solve, you're going to integrate this equation, substitute the initial condition, get the solution. Now, what is the inverse problem? The inverse problem is when the plate is cooling, I have put thermocouples or an infrared thermogram is there, thermometer is there. I'm taking the plate temperatures at various instants of time. So I can take the temperature at 12 seconds, 18 seconds, 24 seconds, whatever. From these temperatures, I want to find out what the heat transfer coefficient is because I don't know what the heat transfer coefficient is. So this is a very simple method to determine the heat transfer coefficient in a situation. Or in a complicated process, if the heat transfer coefficient is unknown, it is bothering you, it is a boundary condition that you don't know, then using some measurements, using some forward model, using an inverse approach. In this case, it is possible to use simple regression and get it. In some other cases, it will not be possible to use regression. Therefore, we'll use other techniques like nonlinear regression or computational statistics, or better still, we'll use a neural network. So this is the approach. So you have to identify what the problem is, what is the unknown, what is measured, what is the governing equation, forward model. So there are no schools of thought where they're saying without the forward model, if there is heavy data available, you can bypass the forward model also. That comes much later. That is a very nascent subject called physics informed neural network. Okay. Now, so I told you the situation. So you have measurements. So this sorts of experiments can be easily done in the lab. So natural convection, that means there's no fan or blower. The plate is kept in still air. Okay, it's a fundamental problem. Integrate it and this thing and then shoot. 5 minutes, get the solution. You got the solution, Subhash?
Yes.
Just wait. And try to identify a parameter called time constant, MCP by HA. Find out the units of this time constant. Subhash, other people who have got the solution. So find out, write the solution in terms of time constant. So there is a time constant for the plate. In fact, if the doctor puts a thermometer, now it's all infrared. This has a time constant of 1 minute or so. That is why 2 minutes it is put. So, okay. So we'll define what the time constant is in a little while. Just go ahead and do it. If three or four of you are saying that you got it, then I'll do it on the board. But I wanted to give you some time so that you do it yourself. I know how to do it and I will do it. Anyway, I will do it. But why don't you try? The goal is to get the temperature as a function of time by solving equation 1 and boundary and initial condition 2. Initial condition means at some particular time E equal to 0. Anand has given something. Okay. Okay, I think it's fine. MCP by HA. Oh.
Hello, sir.
Yeah.
Sir, I had a question regarding this Gauss-Seidel method. Sir, here you have given the condition that AA of II should be greater than summation of Aij from J1 to N, except J equal to I.
J not equal to I.
Yes, sir. So, like, should that condition be strictly met? I mean, what if it is that?
No. Even if it is not satisfied, you can get a solution. But if it is satisfied, the solution is guaranteed. That's what I said. Okay.
Yeah. So, what if the situation is something like the maximum coefficient is individually greater than all the other coefficients, but not greater than their sum?
No, it is possible, but in that case, you may or may not get the solution. You have to go to the actual problem and find out. There is no mathematical answer to that. It is a particular case, you have to solve it and find out. There is no theorem or there is no rule to. The rule says only because it is greater than the sum, it should be more than individual components because modulus is taken. That is granted. But it appears that it is very strict, but it is not really so strict. Because often in heat transfer, the temperature at a particular node is an average of all these temperatures. So that node, the weight or the coefficient for that node will be the highest, correct, compared to the neighboring nodes. So this condition anyway will be automatically satisfied in fluid flow and heat transfer. Okay, so it is it need not cause sleeplessness so much. Huh?
Okay, thank you.
Okay, so it has the units of seconds. You can just check it. This kilogram, joules per kilogram per Kelvin, watts per meter square per Kelvin, meter square. Watts is joules per second. Okay, so the joules per second, the second will come up. This joule and joule will get cancelled. Okay, so this has got joules per kilogram per Kelvin. The kilogram and kilogram will get cancelled. Okay, this has got watts per meter square per Kelvin. This has got joules per kilogram per Kelvin. That 1 by Kelvin, 1 by Kelvin will also get cancelled. Okay, and this is watts per meter square. There is a meter square here that will also get cancelled. So we'll get only a second here. So you can write this solution as so time theta. If you want, you can say Kelvin second. This is theta I. Okay. Now the inverse problem is, suppose you have some measurements like this. Can you get the curve, the best curve passing through all the points? The best curve which won't pass through all the points. The best curve which gives the minimum total, gives the minimum sum of square of deviation of the points from the line. Okay. Now tell me, can linear regression be applied to this problem? Just tell me. Just tell me if linear regression. First of all, is the solution clear? So I want you thumbs up, thumbs ups, thumbs ups. Okay, whatever. Very good. Solution is clear. Manthan, Anand, thank you. Subhash. Okay. Other people, Pala, Shubham, Rishabh, thank you. All right. Vasu, Pratiksha. Okay. So thank you. So now just tell me, can some funda work? Can you linearize this? Linearize this? Pradeep, what are you saying? Oh,
Yes, sir.
can we? You can linearize. There you are. So ln theta, taking ln both sides. Ln theta I minus p by tau. So this is y is equal to b plus ax. So y equal to ln theta, b equal to ln theta I, and x equal to t and a equal to 1 by t. Now the two unknowns could be, see, when you're starting at time t equal to 0, when you look at time and then measure the temperature, our famous Heisenberg said there could be some error. So you can keep the theta I as also as unknown for fun. Though you know it for sure, you can keep it as a unknown and then work out the theta I and see whether whatever theta is given in the problem or when you're taking the readings, whether that is okay or there has been a time lag. Are you getting the point? So you can treat it as two unknowns, y equal to ax plus b. You can solve it, and if you have a lot of data, then you can find out, you can regress this and get the time constant. From the time constant, you can get the heat transfer coefficient. You can also get the initial temperature. Then you can also find out other things, that in time 100 seconds, 200 seconds, how much energy heat has been lost from the plate, how much more energy it is left, what is the average temperature of the plate in terms of energy, blah, 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 all that you can calculate. Okay. So this is, so tomorrow we'll solve the problem with this. Now there's a small spin. Okay. Just rework the problem. Just write down. Rework the problem for the case of t equal to ti. Okay. Rework the problem. Take down. Rework the problem for t equal to ti at time t equal to 0. Rework the problem for the case of t equal to ti at time t equal to the same, but ti is less than t infinity. But ti is less than t infinity. What does it mean? The plate is getting heated or cooled?
Heated, sir.
The plate is getting heated. Just work out the solution and draw the temperature profile, and another 3 minutes we'll close it. Tomorrow we'll solve an example. I wanted to do weighted least squares. We'll at least derive the relation and the problem. I give it as a take home. Okay, because I think we are stuck in here. I am doing Vistar. I mean Vilambit. In classical music. I am doing in Vilambit thought. Everything is. But anyway, I think
in that problem B is already known now, sir.
What is already known?
T infinity minus Ti. Y equal to B plus Ax.
Yeah. It is known. But I am saying it is known with some error. It is doubtfully known. It is doubtfully known. Is that okay? Come on. You can treat it as an unknown and get it out. Even though it is given. Okay. That extra, it is buy one, get one free. It is fun, no? Inverse in heat transfer, it's fun. So you can think of new situations. So this inverse should come in other. Subhash, did you get it?
Yes, sir.
Very good. So let's wait for this last 2 minutes. And then we are done for the day. So we have 2 more minutes, just do it. So we'll just quickly work this out, and I have a problem in tomorrow's class. We'll solve it for the first 20 minutes. Please have your calculators. See, there's also, if you put the ln, you can also plot it on a graph sheet, okay, and get the tau. This was what people did originally before the days of regression. So this is called a visual best approach. Instead of least square, you can take it, you can draw it on a graph sheet and find out, adjust the scale. No, adjust that. This is like using your common sense and basic intelligence, native intelligence. So this is called the visual best. Sometimes the visual best can be very close to the actual answer. Okay. Now, is it causing any gut butt? This heating also is working, right? Subhash?
Yes, sir. Only the excess.
It is a little bit tricky. The form is different.
Yes, sir. Excess temperature will be T infinity only.
So just it will be a little bit tricky. Just do it and keep it in the notes. Depending on my mood, I don't know which question I will ask. Just keep it in the notes. We can complicate this further. There is a heat generation taking place and all that. Once you do all that, linear regression will not work. We will see that in another class. Okay. So it's going to be 10:50. So I wanted to start this problem, but no point in starting at 10:50. All right. So thank you very much. So tomorrow 9 o'clock, we'll solve the problem in this. Thank you. I'm ending the meeting.